Good morning, friends. I'm Professor Jiten Singh Chauhan from IIT Mumbai Remote Center 1241, and I'm giving you a flipped video on the boiler efficiency and the equivalent evaporation. So let's quickly go through some of the basic terminologies as of now. Uh, the boiler rating, when we talked about, we normally want to know that what is the capacity of the boiler as far as the steam generation is concerned. So normally, 1 kg of water at 100 degrees centigrade, the boiler needs to produce steam out of that 1 kg of water. So that will be the equivalent of evaporation. And when we talk about the efficiency, so there are various types of efficiencies we normally adopt as far as the boiler operations are concerned. We have combustion efficiency, thermal efficiency, boiler efficiency, and in the context of what we are trying to study over here, this boiler efficiency is very important, and we do have fuel to steam efficiency, and in some of the cases we use this boiler and thermal efficiency in a single fashion as a single boiler thermal efficiency. So coming back to the boiler efficiency, basically it is the ratio of the heat absorbed by the steam from the boiler per unit time to the heat liberated by the combustion of fuel in the furnace during the same time. So what we are trying is to get that ratio of basically the heat output to the heat input, and that signifies that how much percentage of heat that you have produced in the steam is actually being a part of the heat input, that is your by the burning of the fuel. We'll see a bit more later how this gross calorific values can also be deployed as far as the efficiency calculations are concerned. So we have gross calorific value also, net calorific value, absolute pressure, and atmospheric pressure. These are the important terms also associated with the boiler operation, boiler performance analysis rather. uh, Calorific value is the amount of heat basically liberated by the combustion of the fuel, assuming that the fuel is completely condensed. The steam is completely constant and the sensible heat is made available, whereas net calorific value, we assume that the water produced by the combustion of the fuel is completely remains as a vapor form. So let's quickly see the introduction. The performance of the boiler normally can be done through efficiency and evaporation ratio, basically, which reduces with the time due to the combustion, heat transfer, and poor operations and maintenance. A lot of scaling problems in the water also. So this deterioration of fuel quality and water quality also leads to poor performance of the boiler. Efficiency testing helps us to find out how far the boiler efficiency drifts away from the best efficiency. Any observed abnormal deviations could therefore be investigated to pinpoint the problem area for necessary corrective action. Hence, it is necessary to find out the current level of efficiency for performance evaluation, which is a prerequisite for energy conservation action in the industry. So there is a need so for the the boiler to operate at optimum levels and to consume minimum energy and give the maximum output. That's why I need to assess the performance of the boiler from time to time, and that's why it is paramount to know the performance of the boiler and the efficiency at which it is operating. So mathematically, as you can see, boiler efficiency, heat output to the heat input. Just like any efficiency, fundamentally we define that output to the input, and in terms of the boiler specifically, in terms of the steam output and the heat that is coming by the fuel, that will be as an input in kilocalories. In evaporation ratio, when we talked about, basically defined as the quantity ratio of the quantity of steam generation to the quantity of fuel consumption. This is also known as the input-output method due to the fact it needs only useful output steam and heat input for evaluating the efficiency, as it is shown in the uh, formula. In the block diagram, let's see, as can be seen from the block diagrams, we have fuel input and the air, which is this is the input to the boiler, and normally as an output we should get uh, this is steam output from this another input, which is the boiler. These are the inputs and these are the outputs. See, we have there's the steam basically getting the heat from the water. The boiler imparts the heat to the water and converts it to the steam. Boiler imparts the heat to this fuel and air smoke, and then produces the fuel flue gases. So basically efficiency, again, in terms of this block diagram, we can say this heat addition to the steam to the gross heat in the fuel. How much heat is added to this water to produce this steam, and this heat basically is coming out from this burning by the burning of the fuel. So that's why this gross heat in the fuel becomes as the input, and the heat addition to the steam becomes the output. And the boiler, as far as the boiler efficiency is concerned, in terms of steam flow rate, we have steam flow rate times steam enthalpy minus feed water enthalpy. Enthalpy is basically the heat content of the system. So steam enthalpy minus feed water enthalpy will basically give the amount of heat that is added times the steam flow rate, will give the total heat that is produced, and to the fuel ratio, and as far as the input is concerned, this fuel firing rate times the gross calorific value give you the total heat supplied by the burning of the given quantity of fuel. And this is another way of representing the boiler efficiency. So let's quickly see some of the calculation associated with the boiler efficiency and equivalent evaporation. One of the examples which is shown here, it just talks about some of the the methods which are used to calculate to test the boiler efficiency. Water consumption and coal consumption were measured in a coal-fired boiler at hourly intervals. Rated quantities of coal were fed to the boiler during the trial period. Simultaneously, water level difference was noted to calculate the steam generation during the trial period. Blowdown was avoided during the test. The way through which you measure the various parameters during the boiler assessment. So here's we have the given parameters and the associated data with the high heat output, which is 8 tons per hour of steam that is coming out of the boiler. Steam pressure is 10 kg per centimeter square at a temperature of 180 degrees Celsius. Enthalpy at 10 kg pressure is 665 kilocalorie per kg. Feed water temperature is 85, and enthalpy of feed water is 85 kilocalorie per kg. See the heat input data. We have quantity of coal consumed 1.6 tons per hour and gross calorific value of fuel. So we have give all the given parameters. These are the output parameters, these are the input parameters. So what you got to do, we know the formula. Boiler efficiency is QH minus H by Q GCV times 100, where Q is the quantity of steam generated per hour. Steam generated excuse me, generated per hour. Small q is the quantity of fuel used per hour, or GCV, gross calorific value of the fuel, enthalpy of the steam, and enthalpy of the feed water. Just plug in those values which we have as already given in the question, and then what we'll find out that the boiler efficiency is coming out to 72%, and the evaporation ratio, which is the output steam which is produced per hour to the fuel consumed per hour. So this ratio basically is coming out as a 5. So this is this way we can calculate the boiler efficiency and the equivalent evaporation ratio for the boiler assessment. Let's quickly see some of the factors which affect the boiler performance. See, we have if there are dust and dirt that deposits to the boiler, sometimes the hardness of the water does create those problems of deposits which needs periodic cleaning. This can affect the boiler performance as far as the heating is concerned. Periodical soot blowing, proper water treatment program, blowdown control, draft control, excess air control, percentage loading of the boiler, steam generation, pressure and temperature, boiler insulation, quality of steam, quality of fuel. All these are the factors, if not considered properly, may lead to the poor performance out of the boiler. So all these needs to be controlled periodically, and perhaps the best operation then only will be coming out of the boiler, and based on the efficiency uh, data which can be obtained from a particular boiler, maybe after some period, the same test and the calculations can be run again to see whether there is an improvement in the efficiency, or there is a uh, this degradation of the efficiency. In case the efficiency degrades, then we have to think about what are the factors that basically affect the performance. So in that sense, these are very important. So thank you.